We pour billions of dollars into researching aging in an attempt to find something like the elixir of life or the fountain of youth. What once felt impossible might actually bring us results soon. The desire to escape death has been around for as long as we can remember, and if we can't achieve it through recoding our genes, we attempt to reverse aging using plastic surgery, anti-aging creams, or eating healthy. Well, the last one is a bit of a stretch. We've developed treatments for what were once untreatable ailments so we could live longer, but that's not nearly enough. With all the technology we have today, can we now cheat death? Are you interested in the strange and the unknown? Subscribe to Fact Monkey and ring the bell for more mind-blowing content. Imagine if you could go asleep for 100 years, wake up in the future, and then be totally fine. Seems like science fiction, but preserving a body and reviving it might actually be possible. The science behind it is called cryogenics. A cryogenically frozen thing, whether it's a person or otherwise, is something that has been put in freezing temperatures. A thing is also cryogenic if it can be liquefied at or below minus 240 degrees Fahrenheit or minus 151 degrees Celsius. Nitrogen, the most abundant gas in our atmosphere, becomes liquid at minus 320 degrees Fahrenheit, so it can be considered cryogenic. Therefore, putting something into liquid nitrogen would make it, if only for a few moments, cryogenic as well, and even preserve it for a while. Cryogenics is the process of using that procedure to store a human corpse in low temperature freezing chambers with the hope of resurrecting it in the future. There have been attempts to do this in the past. They were mostly performed in the 60s and 70s, but they ended up failing and companies going out of business, and their stored corpses were thawed and disposed of. But we've come a long way from then. We have yet to successfully revive humans under cryopreservation, but similar experiments have been conducted on other mammals like dogs and monkeys. They haven't been frozen to cryogenic temperatures, but they have had their blood replaced with a protective solution and cooled to 0 degrees Celsius or 32 degrees Fahrenheit, followed up with rewarming and revival. Nematode worms have been preserved in liquid nitrogen and revived too, but there are specimens we have cryopreserved and brought back. Insects, vinegar eels, and some types of human brain tissue as well. At the rate our technology is going, bringing back a human being shouldn't be too much of a task. How does it work? When your heart stops beating and you are declared legally dead, an emergency response team jumps to its feet, and from there, it's a race against time. The team stabilizes your body and supplies your brain with enough oxygen and blood to preserve bare minimum functioning until you can be moved to a suspension facility. On the trip there, your body is packed in ice and injected with heparin, which is a collagen, to prevent your blood from clotting. At the facility, there's another team waiting for you, and here, the actual freezing begins. Cryogenics aren't just about dumping you in a vat of liquid nitrogen. If that's what you thought, the water inside your cells would freeze, and when water freezes, it expands, causing your cells to shatter. Not a pretty image, right? No, the cryogenics team will first remove the water from your cells and replace it with a glycerol-based chemical mixture. Think of it as a human antifreeze. It prevents ice crystals from forming inside you, and the process is called vitrification, which is deep cooling without freezing. Your body is cooled on a bed of dry ice until it hits minus 202 degrees Fahrenheit. Next, you're put into an individual container, which is then placed into a large metal tank filled with liquid nitrogen at minus 320 degrees Fahrenheit. Your body is stored upside down, so if there's ever a leak in the tank, at least your brain would stay immersed in the freezing liquid. I wonder if an actual accident led them to decide to store bodies upside down. Now, revival means doing a lot of damage repair. It means repairing the damage from lack of oxygen, any toxicity caused by the antifreeze, thermal fracturing, and then finally reversing the cause of the actual death. In many cases, extensive tissue regeneration would be required. So does that mean it will never happen? Of course not. For most human history, we thought there was no way to bring back someone whose heart had stopped. And now? It's pretty much a routine procedure. Going by that logic, someday soon we could have technology that repairs biological damage that's irreparable today. The aim of cryogenics is to preserve bodies in a stable environment until that technology arrives. Right now, the oldest patron in cryopreservation is Dr. James Bedford, who was preserved in 1967. He has essentially survived the Cold War, the Vietnam War, Watergate, and the 9/11 attacks. How many people could say that? He was last observed in 1991, and he seemed alright then. As alright as you can be cryogenically frozen in a chamber, that is. In addition to that, we have 146 bodies in the Alcor Life Extensions facility waiting to be revived someday. Interested in the procedure? Well, you better have 28 to 200,000 bucks ready to shell out. If that's too much, you can go for a head-only option, although that's not likely to be light in the pocket either. It's called cryopreservation, and it's the practice of separating a patient's head from their body and only preserving the head. This might not exactly be the fountain of youth we're looking for. Sitting in a cold, dark tank, probably for the foreseeable future, probably isn't how you plan to make it into the future. But it's definitely encouraging other researchers and scientists to find newer ways to cheat death. For example, Sierra Sciences is developing a way to lengthen telomeres, which are the caps at the ends of each strand of DNA. It sounds dangerous to mess with something as critical as DNA, but that hasn't stopped one person from already undergoing the therapy in 2015. Some scientists are looking at other animals and plants that seem to have achieved prolonged lifespans. They're working on a way to make our cells healthier so natural selection can kick in and do its thing. Some are also looking at bacteria and how they have a tidier genetic makeup that could help humans break down the junk proteins in our bodies that cause us to age. We've actually done a whole video on achieving mortality in the future. Just click on the link popping up now, or click the description below. We as a species might not require a long lifespan immediately, but once we figure out a way to travel outside Earth and start colonizing new planets, it will become a necessity. If a trip to Kepler 452b, affectionately called Earth 2.0, takes 26 million years, we're going to need two things: unlimited access to every streaming service on Earth, and of course, immortality. Now, immortality may be a little out of reach, but preservation definitely isn't, and right now, freezing our bodies may be the key to long-distance space travel. The president of SpaceWorks, John Bradford, is currently working on a tech for space exploration that will allow the crew to hibernate during long journeys. If everyone is asleep, it reduces the amount of food and life support systems required on board, which will bring down overall ship mass and costs significantly. The way they're planning to do that is therapeutic hypothermia. It's a procedure surgeons use to treat patients who have had a heart attack or traumatic brain injury. It involves cooling the body, which slows down the heart rate and lowers blood pressure, so the surgeon has more time to treat these issues. The patient would stay in stasis for around 2 to 4 days, although in some cases, they stay like that for 2 weeks. The medical equipment used for therapeutic hypothermia can easily be modified for space travel. It's already a small, low-powered, portable pod-like thing carried round in ambulances. SpaceWorks chamber will look a lot like what you see in Hollywood movies, but they will have some key differences. Generally, in movies, you have individual pods with their own temperature controls, but that adds a lot of weight to a spaceship meant for intergalactic travel. So instead, theirs will be an open, shared status chamber. I don't know about that. Sharing a pod with complete strangers and we're all practically immobile and sleeping? Apparently, these chambers will also have robotic arms and monitoring systems that take care of the passengers, plus small transnasal tubes for cooling and warming systems to bring them back from status. Okay, the robot arms sound cool. I'm on board now. So, would you choose to freeze yourself for the foreseeable future after death? Would you like to wake up to a whole new world about 100 years from now? Let us know what you think in the comments below. If you enjoyed this video, hit the like button and check out more videos about the future on our channel. Thanks for watching.